Okay, cool. My name is Johan. I'm a senior researcher at RISE, National Research Institute in Sweden, and assistant professor at Lund University. This is a pet project together with Cailean. We've been working on for about a year, I believe. We were both talking about open source AI, and the big focus on licenses. What is open source AI? What does the licenses imply? Is it open source washing and whatnot? And I think this follows up on the long definition process. Well, we were more interested in, okay, but how is open source as a collaboration model actually being implemented? And following on from the previous presentation, with open source AI, we're not just talking about source code. Now we're also talking about data. We're talking about compute. We're talking about the non-technical things and the models. And with open source AI, or open weight models. It's about the weights, the parameters. Less focus on what goes on behind the weights, the data, and so on and so forth. So our study called the Cartography of Open Collaboration in Open Source AI. And when we say open source AI, we talk about more permissively shared models. So not all of these models that we've surveyed aligns with the open source AI definitions. We are very transparent with that, but we are much more focused on the open collaboration model implied by open source. So open source firsthand defined by the license, but we're looking more into the open collaboration model. So we interviewed and talked to about 14 open large language models and the individuals behind these projects, and quite diverse sample. And we got to see a lot of different ways in how collaboration can happen across different types of projects. And so this is a team effort between me, Cailean, but also Jennifer Ding and Ben Burtonshaw. Yeah, and we've been working on this on and off for about a year now, so it's nice to finally be able to present some outputs. And just for some background, I think you all know that the models are exploding, being added day by day. Hugging Face is the platform now, just as GitHub is for open source software. And there are a number of models that are really exploding and forming like the foundation for the future ecosystems of open source AI. So it's really expanding, and open source weights or open source AI models, however we define it, the open models are keeping pace and catching up. But what is open source AI? We have the open washing aspects in terms of licenses. What's open, what's not? Is it enough with the weights, or what kind of information do we need about the training data? The open source AI definition goes to a certain extent. Then we can talk about the model openness framework from the Linux Foundation that goes a bit beyond, with their open science definition. We have the digital public goods definition, talking about AI DPGs. Also adding on different layers of requirements of what is and what should be open in this regard. And then there's also this, as was mentioned in the previous presentation, these different artifacts involves different ways of collaboration or development that we need to recognize. It requires different resources, different ways of coordinating and governing. And limited openness before the release of the weights. Again, typically it's only the weights that gets released, and then then comes the questions about, okay, but what data went into this? What about the transparency? That now we are seeing more and more calls for regulation. So open source AI, what does this really imply? And we have the open source AI definition as a foundation, saying it requires open source licenses are used for AI systems and its constituent parts, being, for example, model weights, codes, and training data, or at least sufficiently detailed information. We can also talk about the openness throughout the development, the reuse, maintenance lifecycle. So typically the focus is, okay, now we release something with open weights, and this is where the collaboration happens. But we were more about, what about before the weights gets released? How does collaboration, how does open collaboration happen in the pre-training and post-training phase when you develop if you're developing a model from scratch, for example, with the data collection, the data curation, about the training frameworks that's used, about the model design, and there was this mention of the asymmetric infrastructure access. These developments, or these trainings, they need access to core compute, and that's not always achievable. So there are different ways, different new types of contributions that we need to recognize. So that's the background, and then for a brief summary of the methodology. So we were explicitly asking where and how does open collaboration take place throughout this development and reuse lifecycle of open LLMs specifically, being a proxy for open source AI. We sampled or talked to 17 developers across 14 open LLMs. We had licenses generally permissive, some more restrictive. For example, we included the Llama model as a reference point. We had a quite good representation, although not South America. And we have different projects with grassroots, non-profit research labs, public entities, and industry and startups. And here's a geographical representation of the different models. So you can see we had both a lot of American and European, but also Southeast Asia. But we have a big black spot here, so hopefully that's an area for future work. Some key findings. So starting off, we can talk about how these different projects are organized or governed on a very high level, and generally it's a big difference to open source software communities in a way, because there aren't really these community-driven projects in a sense. There are across the board there are some form of quite organized governance or coordination structure, typically enabling some kind of corporate or a more organizational collaboration. We have the company projects where we saw these single company LLM projects, typically comparable to the single vendor open source projects that we see, for example, in database and whatever. We have the Llama model, for example, by Meta, and Small LM by Hugging Face. So in these cases, it's one company basically driving the show, deciding on where it goes, what kind of requirements that goes in, and if there is any contribution, the single company acts as the final decision maker in everything, and basically or mostly does all of the development internally, although there are points for collaboration, which Cailean will talk about. We didn't see this in the sample, but we are seeing these multi-company projects as well. For example, the Big Code project. So again, this is not something that we saw in our interview sample, but we just wanted to highlight there are other other options as well. And then there was one category of research institute projects. So a lot of these projects were really initiated and governed by research institutes, both private and public. Some by single institutes, and some by more cross-organizational R&D initiatives. Again, where there's a more scientific agenda behind the development, whilst there can be more commercial agendas in the company side of projects. And then there's the grassroots projects, which maybe aligns mostly with the community-driven examples in open source, where there are still these quite rigorous structures. So not just like communities in the wild. There are some form of setup around them. For example, the PIFIA models developed by Linåker AI, a US nonprofit, although they are backed by, for example, I believe Google and a lot of others. But another interesting example is BLIC, which is came out of a group of researchers and the community developers in Poland. So they saw a need for an LLM focused on the Polish language. So they started out with collecting data, but then they were offered space on the national research compute infrastructure in Poland, and that started off their journey into training a foundation model for the Polish language. So that they created their own non-profit for that organization, highlighting a more community approach. And then the more vendor-sponsored grassroots projects, we can talk about Bloom, which is one of the maybe more famous OpenLLM projects. While they were very very large and very grassroots-oriented, we can still talk about a vendor sponsor here in terms of Hugging Face, who was very involved in the coordination and everything. So there was a big commercial representation in this project as well. So we can see the different types of OpenLLM projects taking place here, with a focus on structure, rigor, and organization to enable more corporate contributions and so on, and a bit more coordination as we're talking about different kinds of artifacts, data, training, with the various artifacts which require a more organized approach maybe.
Thank you. Good afternoon, everybody. So I'll continue with our key findings, and I'll start here with cathedrals and bazaars. So it's 5:10. It's been a long day. Maybe some of us are tired. I know certainly many of us are jet lagged. So I thought I'd just start the second part of the presentation with some audience interaction. So question number one, or actually it's not a question. Please raise your hand if you are familiar with the concepts of the cathedral and the bazaar in the context of open source software development. Excellent, so that's most of you. And then number two, does anyone here feel comfortable explaining very briefly what these concepts mean in the context of open source software development? So we have one hand here. You don't have to, but...
Yes.
Cathedrals are built from a systemized framework with really good plans, and bazaars are like, that'll do, let's put that shit here.
Okay, nice. Does anyone else have
any other definitions?
Complementary or competing? Jennifer?
Cathedrals have walls, and the software is developed within this more closed environment. As a bazaar, it's very free flow, like people come and go, ideas are openly expressed.
Brilliant. I can work more with that than that, but I really appreciate you. Yeah, so certainly. I mean, so these concepts were coined by Eric Raymond, right? In his essay, I think came out in 1997, and then his book came out in 1999, in which he calls them his musings, or we could call them ethnographic observations about ways in which developer communities were organizing their development processes for free software at the time. So cathedrals were kind of exclusive groups developing software internally, but then releasing the source code, versus bazaars. And the bazaar he saw the initial Linux community. These were tinkerers, hackers, enthusiasts, researchers who came together, collaborated and discussed in forums, and developed software openly and shared it openly. So why am I bothering you and quizzing you about a book that came out in 1999? Well, the reason for that is that one of the interesting findings in this research project, and Johan said that we worked on this for years, for 1 year, interviewing developers of various open or open weight LLMs, and we found that across the 14 projects and across the various types of organizing models and governance frameworks, from grassroots projects to kind of big tech projects, The projects, what they all had in common is that they were neither just cathedrals nor just bazaars, but actually a bit of both. And so at some stages of the life cycle, they resembled more cathedrals, and at others, they resembled more bazaars. So in a nutshell, the training stages, so number 1 and 2 here, we characterize as cathedral approaches to development, even in the grassroots projects. And the reason for that largely is that it's really expensive to develop LLMs. It requires a lot of technical expertise. And the whole process is just not really optimized for having, let's say, 300 people involved. So typically it's just small teams planning those stages. And I'm really glad that Marco presented just before us about the various interdependent open artifacts that you know, are relevant and in the open source AI space, because we found that even when there are kind of these cathedral approaches to development of LLMs themselves, those developers are interacting with lots of communities of practice, developing relevant open technologies, whether it's open data sets for training models in certain languages or open source frameworks for training or evaluating LLMs, as well as forming partnerships for compute access, for example. The same goes for post-training. Post-training, as you may have seen in one of the slides that Johan presented, is really a stage of kind of optimizing model behaviors and capabilities, maybe aligning it or fine-tuning it for certain domains. It could also be, it's also often the step when developers do instruction fine-tuning, so training LLMs to be able to be used and deployed in kind of chatbot scenarios. And then finally, in the post-release, typically is characterized by this bazaar approach. So the weights are shared, you know, with various licenses. As Johan mentioned, we look at mostly models with permissive licenses, but we had 2, Llama and Bloom, with different types of restrictive licenses. So all the collaboration that goes on there in terms of derivative development, benchmarking, science, creating demos, etc. But still, there are several challenges. Those include gated licenses and kind of gated access mechanisms. So for example, Llama not only has a restrictive license, but also you have to apply to be able to use it and mention which country you're from. And we found that developers from China, for example, have not been able to access the model for that reason. And also another challenge is the velocity of releases of LLMs. Other researchers have described communities on the Hugging Face Hub as nomadic communities, who kind of flock to a new model when it comes out, but then the next week a new model comes out, and then they flock to that. So that's quite different from you know, open source software development as we know it. So I know we're behind on schedule and we don't have much time, so I'm going to fly over this part of our presentation, but actually most of the paper that this presentation is based on is dedicated to documenting what we call open collaboration challenges and on-ramps. On-ramps meaning like enablers or opportunities for collaboration. So I think it's like 30 pages on this paper is just, you know, describing the experiences of all these various projects and what they had and across the various artifacts that Marco, you know, helpfully mentioned. So open source software, open data, we cover compute partnerships, we also cover kind of open science projects. Let's just start quickly with pre-training stage. And I hope that the text is not too small, but so just the key kind of challenges that we see in the pre-training phase are, 1, a lot of secrecy. So normally the pre-training stages, you know, the information that we have about them when those are developed in like cathedral approaches are from the technical reports, but there are different levels of transparency that are shared in these technical reports, and some actors are more selective than others in what they like to share about that. And there are various reasons for that, including, you know, trying to keep their secret sauce to themselves, maybe concerns about copyright issues, the training data that they're using, etc. Another one is, this second one here is about the resource requirements, meaning that the development process has to be planned ahead. And this is from AI2, which is the Allen Institute for AI, who are kind of famous in the community for kind of really pushing the boundaries of truly open source AI. You know, they release training code, they release the training data sets with their models and really extensive documentation. They say, you know, we really have to plan every step in advance, and that really is not conducive to spontaneous collaborations. Another one is the small teams and the expertise required. So we heard from the Speaklish Foundation in Poland that it's just really unoptimized to have 300 people involved in this process. So they have a team of like 10 people who work on the model architecture and experiments. And then the bottom three are related to data. So we heard from the National Library of Norway that data work is just not that sexy. It's tedious, it's slow, everyone wants to work on models, so it's really hard to get people involved in data projects. Curating data is also very expensive, so typically, and a source of competitive advantage, so companies are less excited about sharing that, they like to keep them themselves. And then also a third challenge is copyright issues. So we heard from some developers who wanted to, shared software, shared models, shared a lot of technical documentation, but didn't share data because their lawyers told them that they shouldn't. But there are some collaborations. So the first one I'll mention is around training data sets, and that's in particular for medium and low resource languages. So as we heard from developers in Thailand, said building data sets is one of the easiest things for us to collaborate on. Thai is a medium to low resource language. There aren't a lot of high quality data sets, and the research community understands this. So just to elaborate on that, researchers working in this space at various labs in the country shared this pain point, knew each other, and just said, come on, let's go and work on creating data sets and sharing them. We also heard this from Masakane, which is an organization developing data sets for African languages. So this is kind of different problem set, so not just developing for Thai, but there are thousands of languages in Africa which are terribly underrepresented in NLP. And so what they've been doing is developing data sets for various languages and also training models for, based on them. Another collaboration is actually just creating data sets for specific use cases. So DeepSeek released a model for maths called DeepSeek Math, which is really good for math, but they didn't release the training data set. And the Hugging Face team that developed Small LM, which Johan mentioned, wanted their model to be good at math. So they just recreated a data set that they thought would approximate that data set that DeepSeek had and shared it with a kind of open source math LM community. And then other ones that I'll just quickly mention are contributing to open source frameworks used for training and evaluating LMs, and also compute partnerships. So Bloom is probably the most famous example, or was one of the first examples. It was coordinated by Hugging Face, had over 1,000 volunteers from 250 organizations or so. But we found out that actually the reason why they started that project was because a public compute cluster in France actually just approached their chief science officer and was like, hey, we want to test this new infrastructure that we're creating. Do you guys want to train a model on it? And they were like, okay, yeah, we're going to use this like open science grassroots approach and develop this model. So that's actually the origin story of that. Okay, we're short on time, so I'll just go over this one quickly. This is where we got, saw the least kind of collaboration, and that's because the model is trained but not released yet, and they're just normally working on kind of optimizing the model. But still, there are some examples of collaboration. So Hugging Face shared the intermediate checkpoints of their small model with trusted partners for them to use them on various use cases and share feedback with them. So that, of course, that's not open collaboration, but we still see it as a type of collaboration using, involving other stakeholders beyond just the developers. And the Beijing Academy of AI also released post-training data sets with a community, which has, they said, has been used by over 130 model developers. So that's a nice example. Okay, now finally, the post-release phase. This is really the bizarre, where the bizarre approach is the most visible. I've flipped the order, so starting with the kind of collaboration on-ramps because they're the most obvious, and I think you'll probably be most familiar with them. So the first thing we heard is, Hugging Face Hub is like indispensable infrastructure, and the team at Hugging Face work with OpenLLM developers to help them get their models on the platform. Of course, it's in their self-interest, but really just diffuse it and get it in the hands of various researchers and developers. Community feedback is a really easy way for to enable collaboration. So Speaklish Foundation that in Poland released a toxicity survey, enabling with like an interactive app so people could use the model on various use cases and if they could report on whether the content was toxic or not, and they got over 60,000 responses. Then derivative development, we see so much of this. We have all these kind of model families and trees emerging. But Masakane, for example, took Llama and fine-tuned it on data sets that they created for various African languages, and for 20 African languages, and it outperformed Llama on one of the most common benchmarks. And then natural segue to benchmarking. Masakane has launched AfroBench, which is a leaderboard on Hugging Face Hub, and it evaluates the performance of multilingual models for African languages. And other researchers and developers can contribute models to that leaderboard. And so there's a lot of discussion happening on the kind of edges of that leaderboard. And then the last two are catalyzing follow-up projects. So we're talking a lot about Bloom, and then the developers from Hugging Face took the key learnings from that and then launched Big Code, which is a project for creating an LLM for code. And that's a collaboration with ServiceNow. And the final one is just regional adaptation and use. And kind of here we saw, for example, in Southeast Asia, the sea lion models developed by AI Singapore being used by Go2, which is a super app in Indonesia for their customer service support. And I realize this is just a lot of information and a lot of kind of insights to what various kind of on-ramps and collaboration. So this is the last slide. You'll be happy to hear. So there's a lot of collaboration happening at the post-release stage, but still a lot of challenges. So here are four that I wanted to highlight. So the first is gated access mechanism. So we see this with Llama. So developer at Ant Group in China cannot use Llama because he's in China. Another one is that he reported is network firewalls make it difficult to collaborate in real time. So what they do at his team is they work internally and then have regular releases and share that with the community. So they have this weekly cadence of interacting with others. A third one is from the National Library of Norway is that they share their code because they really are dedicated to open science principles, but it takes a lot of effort and time to make the code reusable and legible. So they said that, okay, they released it, but they haven't had much engagement, and they actually don't expect much engagement because that's not really the point. The point for them is just to share it. And then the final one is sustaining collaboration given the velocity, which I mentioned earlier. Models are coming out so quickly, and kind of developers are flocking from model to model, so that's a major challenge. So I see Nick approaching me, so we'll just wrap up here. So thank you very much.